Hi, welcome to the screencast for Charles Law. Charles Law, the lab is not difficult to do, but it's a little bit confusing because we need to do a couple different steps to get our data. The first thing under procedure, the getting started, says assign 5 volunteers to maintain separate water baths of 35, 45, 55, 65, and 75 degree water throughout the class period. So what I'll have is I'll have the water baths set up, the 5 water baths. I will have a label at each station telling you what temperature it should be, and we'll get 5 volunteers. And basically your job is to make sure they don't get too hot. We don't usually have a problem with them being too cool, but there'll be a thermometer in there, and if you're assigned to one of the water baths, you'll have a beaker of ice there so you can add ice as you need to, or if you need to, you can adjust the heat on the hot plate as well. So once we have the 5 temperatures established, then we also need to know room temperature, and I'll simply take that at the front of the classroom and announce room temperature to everyone. Once we know room temperature, you can fill that in on your data table. And then we're on to the next part, finding the volume of your pipette. So each group is going to pick up a pipette. This is just one of these plastic pipettes that we've used a lot in here. And we're going to see how much the gas expands in here when we heat it up in different water baths. And just like Charles Law predicts, and just like we know from our own experience, gases should expand when they heat up. So we're going to allow it to heat up. We're also going to allow the gas to escape through the top, and then we're going to try and measure how much gas escapes. So first thing we need to know is how big is this pipette. So what we're going to do is we're going to fill the pipette up with water and count how many drops fit into it. Believe it or not, this might be the hardest part of the lab because as it says in step 3, you have to fill your pipette with water completely full, no air bubbles. Do this by submerging the pipette in water and squeezing the bulb until all the air is out. So I'll have some green baskets around the lab stations. If you take your pipette, the trick is to squeeze the bulb as flat as you can between 2 fingers, and then keep the tip, just bend the tip a little bit, and when you submerge it into the water, you want the tip just below, and then the bulb should fill up with water, and the little bit of air you have in there, you can just squeeze, and if you squeeze slightly on the bulb, that air will go out, and then water should be drawn back inside. So if I do this, I know you can't see what's happening down in the basket here. If I squeeze it, the bubbles come out. And I'm getting close, but I've still got a few bubbles in there. If you have bubbles, if you tip it up and tap it, you'll get all the bubbles to gather in one spot. That might help you get them out a little quicker. If you can't get all of your bubbles out, just call me back. After 30 years, I've gotten pretty good at getting bubbles out. Again, tapping will tend to make the bubbles move up. So I'm just going to, one more time. So now I've got it completely full, and as I look at it, I don't see any air bubbles in there. And then I want to drop the water from this pipette and count how many drops are in here. So it's important that you wipe it off. I'm just wiping it off with my hands, but my hands are dripping a bit too. So I would suggest you get a paper towel and make sure you have any extra water off. And then you're just going to start dropping it in, 1 drop at a time. 1, 2, 3, 4, and you're going to do this until you've squeezed every drop out of there. And you want to try and keep each drop the same size, so have the same person doing it. It'll take you a little while. Again, this is the, like I said, probably the most difficult part and definitely the most cumbersome part or the most meticulous part of the lab. But you need to find out how big this pipette is when it's filled with room temperature air. Okay, once you have found out how big your pipette is, it says repeat this step and be sure your two answers are close to one another within 10 drops. And most of these pipettes are around 100 drops is the volume. So record both measurements in your data section. So that's going to be right here, 1 and 2, and you're going to go ahead and average it. And when we come over to your next data table, you can fill that in. This could be your average volume of your pipette. It's not going to change, as it says, see the table above. So go ahead and fill that volume in across. We know what the starting volume is each time. Then, checking to see if gas expands in hot water. Step 5 on the next page says holding the empty, and by empty I mean just air in it, don't have any water in here. Hold the empty pipette by its stem. Immerse the bulb in 35-degree water. The stem should be up and it should be open. So I'm going to stick it in here. I'm going to immerse the pipette as far as I can. There'll probably be, several groups doing this at the same time. That's fine. We've got a big water bath that should be able to handle several pipettes at once. Then it says after you've held it underwater for 2 minutes, again allowing the gas to heat up and expand, and probably some of it expanding or some of it escaping, even though we can't see that. Step 7 says seal the end of the pipette with your finger. So it's important you plug the end here before you pull it out, because as soon as you pull it out of this water bath, the gas in here is going to start cooling back down to room temperature. So we don't want any outside air to be drawn or pushed in here. So I'm going to seal it with my finger. And then it says submerge it in a basket of cool water. So I'm going to go ahead and submerge it in here. And by submerge it, I mean get the whole thing underneath, and you might need 2 hands to do this. And once it's underneath, remove your finger from the end. And now I'm just going to go ahead and let it cool down for a minute. And as it's cooling down, you want to hold it underwater, but you also want to be careful that you're not squeezing the bulb and affecting the volume in there in any way. Okay, and then once you've allowed it to sit there for a minute, step 8 says remove the pipette from the water bath with the opened end facing up. And you may not even be able to see that any water has gone in there. If it's only in the stem, you may not be able to see it. And it says dry off any water on the outside of the pipette. Then turn the pipette over and squeeze any water out that's inside of it. And again, make sure my hands and the pipette are both dry. And I'm going to try and count my drops, squeeze them out the same size as I did before. I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 drops that squeezed out of there. So this is the water that was pushed into the pipette as the gas cooled off. This is step 9 I'm reading. And it's going to help us calculate the total expansion of gas at each temperature. It says record the number of drops in your data table. So again, looking at the data table, this is going to be the drops of water from step 9. So at room temperature, there's 0. It's not going to expand at all. But at 35, I would enter my 9 drops here, and I do the same thing for the other water baths when I get to it. Looking back at step 10, it says repeat this for the other 4 water baths, record the results. And then step 11 says to find the total volume or expansion at each temperature, add the volume of your pipette to the drops of water you measured. So I'm going to take the average volume of my pipette, the number of drops I counted in there, and add it to the drops that it expanded up here to get my total expansion. So if my pipette had held, let's say 100 drops, it expanded 9 drops, my total expansion would be 109 drops. And then as step 12 says, we'll get a data table going, a spreadsheet going for the classroom, and we will come up with class averages for this as well.